Alright, let's dive into something that's both mind-blowing and a little terrifying. The science behind those jaw-dropping lava fountains. You know, the kind that make you question whether you're watching a nature documentary or a sci-fi movie. But here's the kicker. Scientists have just uncovered a new piece of the puzzle, and it's all about superheated magma. Personally, I think this discovery is a game-changer for how we understand volcanic eruptions. Let me break it down for you. So, imagine you're a magma chunk deep inside the Earth. You're hot, but not superheated hot. Then, suddenly, you get this massive heat injection like someone turned up the thermostat to 11. What happens next is fascinating. This superheating doesn't just make you hotter. It dissolves the tiny crystals that usually act as seeds for new crystal growth. What makes this really interesting is that these crystals are like the scaffolding for magma. Without them, the magma stays more fluid, which can completely change how it erupts. It's like the difference between pouring water and pouring honey. One flows fast, the other doesn't. Now, here's where it gets even cooler. Researchers from the University of Manchester and their team recreated this process in a lab. They took magma from the 2021 Tajogaite eruption on La Palma, Spain, and basically gave it a front-row seat to a volcanic spa day, superheated conditions and all. Using X-ray microtomography, they watched in real time as the magma behaved in ways they'd never seen before. One thing that immediately stands out is the delay in crystal formation. In normal magma, crystals start forming after about 20 minutes. But with superheating, took more than 8 hours. 8 hours. That's like comparing a sprint to a marathon. What this really suggests is that superheating could be the secret sauce behind those towering lava fountains we see in some eruptions. If magma stays fluid longer, it can rise faster and explode dramatically. But if crystals start forming earlier, the magma gets thicker, rises slower, and you get a gentler eruption. From my perspective, this adds a whole new layer to how we predict volcanic behavior. It's not just about chemistry or gas content, it's about the thermal history of the magma. What many people don't realize is that volcanoes are like snowflakes. No two eruptions are exactly alike, and this research helps explain why. But here's the bigger picture. This discovery could improve volcanic hazard assessments. If we can better understand what makes an eruption explosive or gentle, we can potentially save lives. In my opinion, that's the most exciting part of this research. It's not just about answering a scientific question. It's about applying that knowledge to protect communities. If you take a step back and think about it, we're basically learning to read the Earth's warning signs in a whole new way. So, the next time you see footage of a lava fountain lighting up the night sky, remember this. It's not just random chaos. It's the result of superheated magma, delayed crystal formation, and a whole lot of physics. A detail I find fascinating is how something as microscopic as crystal seeds can control something as massive as a volcanic eruption. This raises a deeper question. What other hidden processes are shaping the natural world around us? Let me know what you think in the comments. Are you team lava fountain or team gentle eruption? And more importantly, what other natural phenomena do you think have secrets waiting to be uncovered?